Now let's talk about solenoids. Solenoids are a lot of fun, but they can be a little bit confusing. Imagine you had a loopy wire. You just take a whole bunch of wires and loop them together and hook them to a battery. You'll have a current go, and everything we know about moving charges and magnetic fields tells us we're going to get something interesting happen. Now think, if the if you form the second loop overlapping the first, then clearly the magnetic field is going to be twice as much. So as you increase the number of loops, you're going to increase the field strength. Now, when you think solenoid, think slinky, all right? A, a solenoid is just a long straight wire that is just coiled into loops. It winds up acting like a magnet, all right? You increase the magnetic field by inserting iron rods. And this induces the magnetic field in the rods, and this adds to the magnetic field of the solenoid and can create very powerful magnets. They use this in many car power locks. Now, let me show you. This is a FET, Colorado FET, of a solenoid. Here we've got, let me reset it. Yes, I want to reset it. Imagine I turn my battery off. All right, chargers are not moving. It doesn't matter how many loops I have. There is no action going on. See, the magnetic field does not change. Now, look what happens when I change the voltage. I turn the voltage. You see, the stronger the voltage, let's see, let's put in a field meter. Here's a magnetic field meter. Watch what happens to the magnetic field as I increase the number of loops. It's going from a total of 2.42. Let's get it lined up here. Okay, it's close enough. See, as I increase the number of loops, I'm increasing the magnetic field. So increasing the number of loops changes the magnetic field, and clearly changing the current is going to change the magnetic field. So you see, the further you get, it decreases. Do you see that the magnetic field looks a lot like a bar magnet? Now watch what happens. Here's my north. Do you see how it flips? Just like a magnet does. All right. Now what? Okay, this is just fun. Let's just do AC. Watch what happens. Do you see how it's flipping back and forth? This is how we get an AC current supply. All right. We're not going to play with these. It's just a lot of fun. If you want to do any investigations on magnetism and pickup coils, I mean, some of this is just really fascinating. FET has done a fantastic job of doing some electrical characterizations. And this one is my very favorite. The generator, folks, this is how a generator works, but we're not going to play with that right now. All right. I need to close that down because I'm going to sit here and want to play with it. Now, so solenoids are very powerful, can be very powerful, and they can be very useful. Now, characterizations. Inside, the magnetic field is very uniform, and the field lines are very closely parallel to each other. Outside, it's not uniform, and actually looks a lot like a bar magnet. Clearly, you can increase the magnetic field strength by increasing the current. I showed you that, and increasing the number of coils per unit length. And an electromagnet is just a current-carrying wire with many loops wrapped around a piece of iron. Do you see the solenoid in there? You're right. Without the iron, it's just a solenoid. Now let's talk about loudspeakers. There is a YouTube video by a young man that I cannot pronounce his name, but we're going to show it. It is Kuram Tanvir that did a very nice, I think he did a very nice job of just giving us some graphics. So basically, I may need to play this a couple times. All right, here we go. Now, there is a sound signal, okay, and it's converted to electrical, and it's sent to a coil. All right. Hold on. Let me go through the parts here. This is the voice coil. We have a north, a south, north, south, but here's the coil. this is the cone. This is the part you see. There's a diaphragm in here. There's signal input, our magnet, and the frame. All right. So the sound comes in. Okay. You get an electrical signal that comes in and it's sent to the coil. All right. From there, you get a current, and the current has a magnetic force, and it acts on the coil itself. When the current reverses direction, you see how it's reversing the direction, the magnetic force, let me restart this, the magnetic force is going to reverse direction. All right, and as the magnetic force reverses direction, the cone accelerates in the opposite direction. Now, you see as a cone accelerates, you get these alternating periods of compression and rarefaction. And you remember from sound, that is sound, okay? So let's just play the whole thing. It's only 16 seconds. It's a nice little video here. All right. You see as the current comes in and as it switches direction, the magnetic field switches, you wind up with the cone flipping back and forth, and you can see you have the sound. Thank you very much to YouTube.